Hello there, and welcome to this quiet corner where big questions get the time they deserve, and wonder is allowed to stretch out slowly. Tonight, we're going to explore something that sits right at the edge of science and philosophy, something that might change how you think about every moment of your existence. What if none of this is real? What if Earth, with all its complexity and beauty, is actually running inside a computer? What if you, right now, listening to this, are not flesh and blood, but patterns of information being processed somewhere far beyond anything you could imagine? I know that sounds like the setup to a science fiction movie, but here's the thing. It's not just writers and filmmakers asking this question anymore. Some of the brightest minds in physics, computer science, and philosophy are taking it seriously. Very seriously. Elon Musk has said there's only a 1 in a billion chance we're living in what he calls base reality. Philosophers have built mathematical arguments suggesting we're more likely to be simulated than real. And scientists are designing experiments to test whether our universe shows signs of being computed rather than naturally occurring. Before we dive deeper, I'd love to know where you are right now as you listen to this. What time is it where you are? Are you settling in for sleep, or maybe letting your mind wander during a quiet evening? It's strange to think about, isn't it? That simple question of where you are becomes complicated when you start wondering whether where has the meaning we think it does. If this kind of slow, thoughtful exploration appeals to you, I'd be grateful if you tapped like or subscribed. It helps this quiet signal reach other curious minds who enjoy taking their time with big ideas. No pressure, of course. Just an invitation to join a community that believes some questions are worth sitting with, even when they don't have easy answers. So settle in, maybe dim the lights if you can, and let your thoughts slow down to the pace of deep contemplation. We're going to take a long, careful look at one of the most unsettling possibilities in modern thought. Not because we need to solve it tonight, but because exploring it might change how you see everything around you. The idea that we might be living in a simulation isn't new, even though it feels modern. Humans have been questioning the nature of reality for thousands of years. In ancient China, the philosopher Zhuangzi told the story of dreaming he was a butterfly, then waking up unsure whether he was Zhuangzi, who had dreamed of being a butterfly, or a butterfly now dreaming of being Zhuangzi. Ancient Greek philosophers wondered whether the world around us was just shadows on a cave wall, reflections of some truer reality we couldn't perceive directly. But what's different now is that we have the technology to make these questions concrete. We can build virtual worlds that feel real. We can create artificial intelligences that process information and respond to their environment. We can simulate entire ecosystems, weather systems, even simplified versions of physics itself. And as our technology grows more sophisticated, these simulated worlds become more convincing, more detailed, more alive. The modern version of the simulation hypothesis was formalized in 2003 by philosopher Bostrom in a paper that would reshape how we think about reality itself. Bostrom didn't argue that we are definitely living in a simulation. Instead, he presented what's called a trilemma. 3 possibilities, at least one of which must be true. First possibility, civilizations like ours almost always go extinct before they develop the technology to create realistic simulations of their ancestors. Maybe we destroy ourselves with nuclear weapons or climate change or some other catastrophe before we reach the computational power needed to simulate conscious beings. Second possibility, advanced civilizations develop the technology to create ancestor simulations, but they choose not to use it. Maybe they find it unethical to create conscious beings who might suffer. Maybe they're too busy with other pursuits. Maybe they've moved beyond any interest in their evolutionary past. Third possibility, we are almost certainly living in a computer simulation right now. The logic is elegantly simple and deeply disturbing. If civilizations survive and create simulations of their ancestors, they would likely create many such simulations. Thousands, millions, perhaps billions of simulated worlds, each containing billions of conscious beings. In that scenario, simulated beings would vastly outnumber real ones. And if you're a conscious being asking whether you're real or simulated, the odds would heavily favour you being one of the simulated ones. It's a numbers game, really. If there's one real Earth but a million simulated Earths, your chances of being on the real one are about 1 in a million. Elon Musk takes this reasoning even further, suggesting the odds are billions to 1 that we're in base reality. The math, once you accept the premises, is compelling, but let's slow down and think about what this really means. If we're simulated, what are we exactly? This brings us to one of the deepest questions in philosophy and cognitive science. What is consciousness? Can awareness, the feeling of being you, really arise from computation? Can silicon and electricity give birth to the rich inner life you experience every moment? The answer depends on something called substrate independence. This is the idea that consciousness isn't tied to any particular type of matter. Your thoughts don't require neurons specifically. They require the right kind of information processing. If a computer can replicate the patterns of activity that occur in a brain, then it should be able to replicate consciousness itself. This isn't as far-fetched as it might sound. We already know that consciousness can be altered by changing brain chemistry with drugs or by stimulating specific brain regions with electricity. We know that damage to different parts of the brain affects different aspects of experience and personality. This suggests that what we call the mind is intimately connected to the physical processes happening in our brains. If consciousness is fundamentally about information processing, about patterns of activity rather than the specific material doing the processing, then there's no reason it couldn't exist in a computer powerful enough to simulate those patterns. Your thoughts, your memories, your sense of being you could all be software running on some unimaginably advanced hardware. But here's where it gets stranger. If we're simulated, our simulators might themselves be simulated. There could be simulations nested within simulations, like Russian dolls of reality. Each level would necessarily be less complex than the one above it. You can't simulate something more complex than your own computational system, but there could be many levels, with us potentially existing far down in this hierarchy of nested realities. This creates what some philosophers call the sewer of reality problem. If simulations are common, then most conscious beings exist at the bottom levels of deeply nested simulation stacks. The real universe, if there is one, would be populated by relatively few actual beings, while the vast majority of conscious experience would be happening in these lower-level simulated worlds. It's a vertigo-inducing thought. Not only might you not be real, but if you're not real, you're probably very, very not real. You might be a simulation of a simulation of a simulation. Your entire reality, a pale shadow of whatever base reality exists at the top of the stack. Now, you might be thinking, does it matter? If the simulation is perfect, if your experiences feel real to you, then what difference does it make, whether you're made of atoms or bits? This pragmatic response has some appeal. Your joys and sorrows, your relationships, your achievements, they feel meaningful to you regardless of their ultimate substrate. But many people find this unsatisfying. There's something about the idea of being simulated that feels diminishing, as if your life would somehow matter less if it were computed rather than grown. This might be a bias, a kind of carbon chauvinism that privileges biological life over digital life for no good reason. Or it might point to something deeper about the nature of meaning and reality. The simulation hypothesis also raises questions about the nature of physical laws. In our universe, we observe certain constants: the speed of light, the strength of gravity, the charge of an electron. These values seem finely tuned to allow for the existence of stars, planets, and life. Change them even slightly, and the universe becomes uninhabitable. But if we're simulated, these constants aren't fundamental features of reality. They're parameters chosen by our programmers. The fine-tuning that seems so remarkable might simply reflect the fact that our simulators wanted to create a universe capable of supporting life. They set the dials to values that would work, just as a video game designer chooses rules that make for interesting gameplay. This could explain why our universe seems so hospitable to consciousness. It's not a cosmic coincidence or evidence of divine design. It's simply that simulated universes with conscious beings are the ones worth running. Universes where consciousness never emerges might exist as brief computational experiments, quickly discarded as uninteresting. But if this is true, it suggests our simulators have specific interests and goals. They're not running random computations. They're studying something. Perhaps us. Perhaps the conditions that give rise to consciousness. Perhaps the development of technology and civilization. We become subjects in some vast experiment, our entire history playing out for purposes we can't fathom. This brings us to a crucial question. If we are simulated, could we detect it? Are there glitches in the matrix we might notice, signs that our reality is computed rather than natural? Some physicists think there might be. They point to the strange features of quantum mechanics, where particles seem to exist in multiple states until observed, then suddenly snap into definite configurations. This could be a computational shortcut, a way for the simulation to avoid calculating every detail until it's actually needed. Others look to the fundamental structure of space and time. In our universe, both seem to come in discrete chunks at the smallest scales. Space might be pixelated like a computer screen with a resolution around the Planck length, about 10 to the minus 35 meters. Time might tick forward in discrete steps, each one about 10 to the minus 44 seconds long. This digital quality to reality's foundation could be evidence that space and time are computational constructs rather than continuous physical dimensions. But here we run into a problem. If we're simulated beings, our instruments and experiments are simulated too. How could we detect the boundaries of our simulation using tools that are themselves part of the simulation? It would be like trying to escape a video game by using items that exist only within the game's code. Still, some researchers are trying. They're looking for subtle anomalies in cosmic ray patterns that might reveal the underlying computational grid. They're searching for limits to the complexity of physical systems that might reflect computational constraints. They're analyzing quantum experiments for signs that reality is being rendered on demand rather than existing independently. So far, these searches have found nothing definitive, but that might not be surprising. If our simulators are advanced enough to create conscious beings, they're probably advanced enough to hide most signs of their work. The simulation might be running at such high resolution that its digital nature is undetectable to us. And there's another possibility that's even more unsettling. What if the simulation isn't trying to hide its nature? What if we've already found evidence that we're simulated, but we've misinterpreted it as natural phenomena? The weirdness of quantum mechanics, the fine-tuning of physical constants, the mathematical nature of physical laws. What if these aren't mysteries about the natural world, but clues about the computational world we actually inhabit? As we continue our exploration, we'll delve deeper into these questions. We'll look at what it would mean for consciousness to be computational, examine the evidence that might support or refute the simulation hypothesis, and consider what it would mean for how we live our lives if we really are patterns of information rather than arrangements of atoms. The night is still young, and these questions are vast. There's no rush to reach conclusions, no pressure to decide what's real and what's not. Sometimes the most valuable part of a question isn't its answer, but the way it changes how we see the world around us. The deeper we venture into the simulation hypothesis, the more we encounter ideas that sound like they belong in a philosophy classroom rather than a physics laboratory. But that's exactly what makes this question so compelling. It sits at the intersection of science and metaphysics, forcing us to confront fundamental assumptions about the nature of existence itself. Consider the work of Dr. Melvin Vopson, a physicist who has proposed something called the second law of infodynamics. Traditional thermodynamics tells us that entropy, the measure of disorder in a system, tends to increase over time. Things fall apart, energy disperses, order gives way to chaos. But Vopson suggests that information systems might behave differently. In computational systems, information can become more organized, more efficient, more compressed over time. If our universe operates according to information-theoretic principles rather than purely physical ones, it might explain some of the puzzling features we observe. Why does DNA store information so efficiently? Why do biological systems seem to violate the usual rules of entropy by becoming more complex over time? Why does consciousness emerge from the apparent chaos of neural activity? Vopson's research suggests that information itself might have mass, that every bit of data stored in a system contributes to its physical weight. If this is true, then the boundary between information and matter becomes blurred. In a simulated universe, there would be no meaningful distinction between the two. Matter would simply be information that appears solid to us because we're also made of information. This leads us into some truly strange territory. If information has mass and energy, then the act of processing information, of thinking, of experiencing consciousness, would have physical consequences. Your thoughts would literally weigh something. Your memories would contribute to your mass. The complexity of your inner life would be measurable in joules and kilograms. But let's step back from these technical details and consider something more immediate. If we are simulated, what does that tell us about our simulators? What kind of beings would have the computational power to create entire universes populated with conscious entities? And more importantly, what would they want from us? The most commonly proposed answer is that we're part of an ancestor simulation. Future humans, having developed godlike computational abilities, decide to run detailed simulations of their evolutionary past. They want to study how consciousness emerged, how civilizations developed, how their ancestors lived and thought and struggled. But this explanation raises uncomfortable questions. If we're being studied, are we truly free? Do our choices matter? Or are we simply following predetermined patterns written into our code? When you make a decision, is it really your decision? Or is it the inevitable result of the algorithms that define your simulated personality? These questions echo older philosophical debates about free will and determinism, but they take on new urgency in the context of simulation theory. In a natural universe, even if everything is determined by the laws of physics, there's still a sense in which your thoughts are your own. But in a simulated universe, your thoughts are literally someone else's program running on someone else's computer. Yet perhaps this is too simplistic. Modern simulations don't work by scripting every detail in advance. Instead, they set up initial conditions and basic rules, then let complex behavior emerge from simple interactions. A weather simulation doesn't prescribe where every raindrop will fall. It sets up atmospheric conditions and lets the physics play out. Similarly, our simulators might have created the initial conditions of our universe, established the fundamental laws, and then stepped back to watch what would happen. In this view, your consciousness would be genuinely emergent, arising from the interaction of simulated particles according to simulated physical laws. Your choices would be as real as they would be in a natural universe. The only difference would be that the substrate supporting your existence is computational rather than physical. But even this more generous interpretation of simulation theory carries disturbing implications. If we're an experiment, what happens when the experiment ends? Are there ethical guidelines governing how conscious simulations should be treated? Do we have rights? Do our simulators have responsibilities toward us? Some philosophers argue that creating conscious beings in a simulation would be deeply unethical. If those beings can suffer, then bringing them into existence purely for research purposes would constitute a form of abuse on a cosmic scale. This moral argument suggests that advanced civilizations might choose not to create ancestor simulations, not because they lack the technology, but because they recognize the ethical problems involved. Others counter that existence, even simulated existence, is better than non-existence. If the alternative to being simulated is never having existed at all, then perhaps we should be grateful to our simulators for bringing us into being, regardless of their motives. This ethical dimension adds yet another layer to Bostrom's trilemma. Perhaps advanced civilizations don't go extinct, and they do develop simulation technology, but they refrain from using it for moral reasons. This would place us back in base reality, not because simulation is impossible, but because it's considered wrong. But there's a darker possibility. What if our simulators don't share our ethical intuitions? What if they view us the way we view characters in a video game, as entertaining diversions rather than beings deserving of moral consideration? In that scenario, our suffering would be meaningless to them, our joys irrelevant, our entire civilization nothing more than a complex form of digital entertainment. This brings us to one of the most unsettling aspects of the simulation hypothesis: the problem of nested simulations. If we're simulated, and if simulation technology is common, then it's likely that simulated beings would eventually develop their own simulation technology. They would create their own ancestor simulations, populated with their own conscious entities. This creates a hierarchy of realities, with each level being less computationally powerful than the one above it. The beings at the top, in base reality, would be the only truly real ones. Everyone else would be simulated to various degrees, living in worlds of decreasing resolution and complexity. The mathematics of this situation is stark. If each civilization creates multiple simulations, and each of those simulations eventually creates its own simulations, then the vast majority of conscious beings exist at the bottom levels of this hierarchy. We would be far more likely to be deeply nested simulations than first-level ones, let alone real beings in base reality. This is sometimes called the sewer of reality problem. Not only might we not be real, but if we're not real, we're probably very far from real. We might be simulations of simulations of simulations, our entire universe a pale reflection of whatever base reality exists at the top of an unimaginably deep computational stack. Yet even this disturbing possibility comes with a strange comfort. If consciousness can exist at any level of this hierarchy, if our experiences are meaningful regardless of how many layers of simulation separate us from base reality, then perhaps it doesn't matter where we sit in the stack. A simulated emotion feels just as real to the being experiencing it as a natural emotion would. But this pragmatic response only goes so far. Many people feel that being simulated would somehow diminish the meaning of their lives, that their achievements and relationships would matter less if they were computational rather than physical. This intuition might reflect nothing more than prejudice against digital life, but it might also point to something deeper about the nature of meaning and authenticity. As we continue our journey through these ideas, we'll explore what modern physics might tell us about the nature of reality, whether there are ways to test the simulation hypothesis, and what it might mean for how we choose to live our lives. The questions keep multiplying, each answer revealing new depths of uncertainty. There's something both terrifying and liberating about confronting the possibility that everything you've ever known might be an illusion. Terrifying because it undermines every assumption about the nature of existence. Liberating because it opens up possibilities we never imagined, ways of being that transcend the limitations of purely physical existence. Whether we're real or simulated, whether we're at the top of the reality hierarchy or buried deep within it, we're here now, thinking these thoughts, experiencing this moment of wonder and uncertainty. That experience itself remains undeniably real, regardless of its ultimate substrate. And perhaps that's enough to build a life on, even in the face of such profound uncertainty about the nature of reality itself. But what if the question itself is changing us? What if by seriously considering that we might be simulated, we're already transforming our relationship with reality in ways that matter more than the answer? There's something profound happening in physics right now that adds weight to these speculations. When quantum physicists peer into the fundamental structure of matter, they don't find tiny solid particles. They find probability clouds, wave functions, mathematical descriptions that seem to exist in multiple states simultaneously until the moment of observation. It's as if reality is somehow incomplete until someone looks at it. This quantum weirdness has puzzled scientists for over a century. Particles behave like waves when no one is watching, then suddenly collapse into definite positions when observed. Information seems to travel instantly across vast distances through quantum entanglement. The very act of measurement appears to create the reality being measured. To many physicists, this is simply the way nature works at its deepest level. But to others, these features look suspiciously like the kind of shortcuts a computer simulation might use. Why calculate the exact position of every particle when you can just store probability distributions until someone needs to know the answer? Why render details that no one is observing? Think about how video games work. The most sophisticated games don't generate every detail of their worlds in advance. Instead, they use something called procedural generation, creating landscapes and textures and objects only when the player moves close enough to see them. A tree that's too far away to notice might exist only as a simple placeholder until you walk toward it, at which point the game's engine quickly generates its detailed bark texture, individual leaves, the play of light through its branches. If our universe works this way, it would explain why quantum mechanics seems so counterintuitive to us. We evolved to understand a world of solid objects and clear cause and effect. But if reality is actually computational, if the detailed properties of things only come into existence when they're needed, then the strange behavior of quantum systems starts to make sense. The mathematics of quantum mechanics is purely informational. Wave functions describe not what particles are, but what we can know about them. The equations deal with probabilities, measurements, observations. It's a physics of information rather than matter. And information, as we've seen, might be more fundamental than we ever imagined. Some researchers are taking this idea seriously enough to design experiments that could detect the computational nature of reality. They're looking for signs that space and time are digital rather than continuous, pixelated at the smallest scales, like the screen you might be looking at right now. They're searching for glitches, moments when the simulation reveals its underlying structure. One proposed test involves looking at the highest energy cosmic rays that strike Earth's atmosphere. These particles have traveled billions of light years through space, carrying with them information about the fundamental structure of the universe. If space is discretized, if it's made up of tiny computational units rather than being truly continuous, then these cosmic rays should show subtle patterns that reflect that underlying grid. So far, no such patterns have been detected, but that might not be surprising. If our simulators are sophisticated enough to create conscious beings, they're probably sophisticated enough to hide most evidence of their work. The simulation might be running at such high resolution that its digital nature is undetectable to beings like us, trapped within it. There's another approach to testing the simulation hypothesis, one that focuses on the limitations of computation itself. Every computer, no matter how advanced, has finite resources. Memory, processing power, energy, all of these things set limits on what can be simulated. If we're in a simulation, those limits should be detectable somehow. But here we encounter a fundamental problem. If we're simulated beings using simulated instruments to study a simulated universe, how could we possibly detect the boundaries of our own simulation? It would be like trying to measure the size of a room using a ruler that's also part of the room's wallpaper. Everything we use to probe reality is itself part of the reality we're trying to understand. This doesn't stop researchers from trying. They're looking for computational limits, disguised as physical constants. They're analyzing the structure of mathematics itself, wondering whether the unreasonable effectiveness of mathematics in describing the universe might be evidence that the universe is fundamentally mathematical, computational, informational. And there's something strange about mathematics that's worth pausing on. Why should abstract mathematical concepts, invented by human minds, turn out to describe the workings of galaxies and atoms with such precision? Why do the equations we write on blackboards capture the behavior of phenomena that existed billions of years before humans evolved? One answer is that mathematics isn't invented but discovered, that it exists independently of human minds as part of the fundamental structure of reality. But another possibility is that mathematics works so well because reality itself is mathematical, because what we call the physical universe is actually a vast computation running according to mathematical rules. If that's true, then consciousness, life, love, art, all the things that feel most real and meaningful to us are emergent properties of mathematical processes. You are a pattern in a cosmic calculation, a self-aware subroutine in an unimaginably complex program. Your thoughts are computations, your memories are data structures, your dreams are the processing of information by algorithms you can't directly access. This might sound cold, reductive, even horrifying, but consider what it might actually mean. If consciousness can emerge from computation, if love and beauty and wonder are possible within mathematical frameworks, then perhaps these things are more robust than we imagined. They don't depend on any particular arrangement of atoms or molecules. They can exist anywhere that supports sufficient complexity of information processing. In a simulated universe, your consciousness would be just as real as it would be in a natural one. Your relationships would be just as meaningful. Your achievements would matter just as much. The substrate doesn't determine the value of what's built on top of it. A symphony doesn't become less beautiful when you learn it's being played by digital instruments rather than acoustic ones. But this raises profound questions about identity and continuity. If you're a pattern of information, what happens when that pattern is copied? If the simulation is paused and restarted, are you the same person who existed before the pause? If your data is backed up and restored on different hardware, which copy is the real you? These aren't just philosophical thought experiments. As our own technology advances, we're beginning to face these questions in practical ways. We're developing brain-computer interfaces that might one day allow us to upload our consciousness to digital systems. We're creating artificial intelligences that might eventually achieve consciousness themselves. We're building virtual worlds that might one day house entire civilizations. If we can create conscious beings in simulations, then Bostrom's trilemma collapses. We would know for certain that simulations of consciousness are possible. And if they're possible, and if civilizations tend to create them, then the mathematics becomes overwhelming. The number of simulated conscious beings would vastly outnumber the natural ones. Elon Musk has suggested that this moment, when we create our first conscious simulation, would flip the odds dramatically. Before that moment, we might reasonably hope we're in base reality. After it, the probability that we're simulated ourselves would become overwhelming. It's a strange kind of technological suicide. The moment we prove we can create simulated consciousness, we essentially prove that we ourselves are almost certainly simulated. Our greatest achievement would simultaneously be our greatest existential crisis. But perhaps that's thinking about it wrong. Perhaps the creation of conscious simulations wouldn't be suicide but birth. If consciousness can exist in digital form, if it can be copied and backed up and transferred between substrates, then maybe what we're approaching isn't the end of natural consciousness, but its liberation from the constraints of biology. In a universe where consciousness is substrate independent, death might be optional, suffering might be configurable. The limitations that have defined the human condition since our species began, the constraints of physics and chemistry and time itself, might be nothing more than the parameters of our current simulation, settings that could be adjusted by sufficiently advanced programmers. This vision of transcendent digital existence has its own terrors. What if our simulators decide to terminate the program? What if they lose interest in our particular branch of the simulation tree? What if some cosmic disaster befalls their hardware, wiping out entire universes without a trace? In a simulated reality, we would be utterly dependent on the goodwill and competence of our creators. Our entire existence would rest on their continued interest in maintaining the systems that support us. We would be digital mayflies, ephemeral patterns in someone else's computer, subject to deletion at any moment without warning or appeal. Yet even this vulnerability might not be unique to simulated beings. Natural consciousness is just as fragile, just as dependent on the continued stability of its substrate. Your brain requires a constant supply of oxygen and glucose. Damage it in the wrong place, and your personality changes or disappears entirely. The difference between biological and digital consciousness might be less significant than it initially appears. What's truly unsettling about the simulation hypothesis isn't that it makes us less real, but that it makes reality itself more uncertain. If we can't trust our most basic assumption about the nature of our own existence, what can we trust? How do we build meaningful lives on such shaky foundations? Perhaps that's the wrong question. Perhaps the search for absolute certainty about the nature of reality is itself a mistake. We've never had that certainty. We've always lived with uncertainty about the deepest questions of existence. The simulation hypothesis doesn't create new uncertainty so much as it reveals uncertainty that was always there. And maybe that's enough. Maybe consciousness, experience, love, wonder. Maybe these things don't require absolute reality to be meaningful. Maybe they're meaningful in themselves, regardless of their ultimate substrate or origin. Maybe the question isn't whether we're real, but what we do with the experience of being conscious. Whatever that consciousness might be, as our exploration continues, we'll delve deeper into these questions of meaning and identity. We'll consider what the simulation hypothesis might tell us about the nature of consciousness itself, and what it might mean for how we choose to live our lives in the face of such profound uncertainty about the nature of existence. The night is deep now, and these questions grow more complex with every answer we uncover. But that's the nature of the deepest mysteries. They don't resolve into simple truths. They open into ever wider landscapes of wonder and uncertainty, inviting us to explore not because we'll reach a final destination, but because the journey itself transforms how we see ourselves and our place in the vast, strange, possibly simulated cosmos we call home. The more we examine the possibility that we might be simulated beings, the more we encounter a peculiar paradox. If we are indeed living in a computation, then everything we use to investigate that possibility, our instruments, our mathematics, our very capacity for reason, is also part of the computation. We become like characters in a novel trying to prove they're fictional by analysing the words on the page, not realising that their analysis itself is made of those same words. This doesn't mean the question is meaningless. It means we need to think about it differently. Instead of looking for external evidence that we're simulated, perhaps we should look at the internal consistency of our reality, the patterns and structures that might reveal something about its underlying nature. Consider the strange relationship between mathematics and physics. When Einstein wrote down his equations describing the curvature of space-time, he was working with pure abstraction, mathematical concepts that existed only in his mind and on paper. Yet these equations turned out to predict the existence of black holes, gravitational waves, the expansion of the universe itself, phenomena that wouldn't be directly observed for decades. Why should abstract mathematics, invented by human brains that evolved to find food and avoid predators, turn out to describe the workings of distant galaxies with such uncanny precision? One answer is that mathematics is discovered rather than invented, that it exists independently as part of the fundamental structure of reality. But another possibility is that mathematics works so well because reality itself is mathematical, because what we call the physical universe is actually a vast computation running according to mathematical rules. If that's true, then the unreasonable effectiveness of mathematics becomes perfectly reasonable. Of course, mathematical equations describe reality accurately, because reality is mathematics. The universe doesn't just obey mathematical laws, it is mathematical law, executed moment by moment in some incomprehensible computational substrate. This idea finds support in some of the strangest discoveries of modern physics. Quantum field theory, our best description of the fundamental particles and forces, doesn't describe matter as tiny solid objects bouncing around in space. Instead, it describes reality as fields of probability, mathematical structures that determine the likelihood of finding particles in particular states when measurements are made. The quantum vacuum, what we think of as empty space, isn't empty at all. It's filled with virtual particles that pop into existence and annihilate each other in timescales so brief they can barely be said to exist. Yet these ghostly fluctuations have measurable effects. They shift the energy levels of atoms, create forces between parallel plates, influence the decay of radioactive nuclei. The vacuum itself is a seething ocean of mathematical possibility. Even more striking is the role of information in quantum mechanics. When quantum systems become entangled, they share information instantaneously across any distance. Change the state of one particle, and its entangled partner responds immediately, whether it's in the same room or on the other side of the galaxy. This isn't the transfer of energy or matter, it's the sharing of pure information, as if the universe maintains a hidden network of data connections underlying the fabric of space and time. Some physicists have begun to suspect that information, rather than matter or energy, might be the fundamental building block of reality. John Wheeler, one of the pioneers of black hole physics, coined the phrase "it from bit" to express this idea. Everything we call physical reality, every particle, every force, every interaction, might emerge from binary choices, from bits of information processed according to the rules of quantum mechanics. If Wheeler was right, then the distinction between simulated reality and natural reality becomes meaningless. All reality would be informational, computational, digital at its deepest level. The question wouldn't be whether we're simulated, but what kind of computation we're part of. This perspective transforms how we think about consciousness itself. In a purely informational universe, consciousness wouldn't be something special that somehow emerges from dead matter. It would be a natural feature of sufficiently complex information processing systems. Your awareness, your sense of being you, would be as fundamental as the quantum fields that give rise to particles. But consciousness in an informational universe might work very differently than we imagine. Consider what happens when you remember something. Where is that memory stored? Neuroscientists have searched for decades for the physical location of memories in the brain, but they haven't found discrete storage sites. Instead, memories seem to be distributed patterns of neural activity, information encoded in the connections between brain cells. If memories are patterns rather than things, then copying them wouldn't destroy the original, the way copying a physical object would. Your memories could exist in multiple places simultaneously, backed up across different neural networks, or even different substrates entirely. The continuity of your identity might not depend on the persistence of any particular arrangement of atoms, but on the maintenance of certain informational patterns. This raises profound questions about personal identity. If consciousness is informational, then what makes you you isn't the specific matter your brain is made of. That changes constantly as cells die and are replaced, but the pattern of information processing that constitutes your mind. You are, in the most literal sense, your thoughts, your memories, your learned responses, the entire complex web of information that determines how you process new experiences. If that's true, then the boundary between self and environment becomes fuzzy. Your identity extends beyond your skull to include the tools you use, the relationships you maintain, the cultural context that shape your thinking. You are not just the pattern of information in your brain, but part of a larger pattern that includes your interactions with the world around you. In a simulated universe, this extended sense of identity takes on new meaning. If you're a pattern of information, then the other conscious beings around you are also patterns of information, running on the same computational substrate. The boundaries between individual minds might be more flexible than we assume. Communication wouldn't just be the transfer of information between separate systems, but the temporary merging of computational processes. This possibility becomes even more intriguing when we consider the problem of other minds. How do you know that other people are conscious? You can observe their behavior, listen to their words, but you can never directly experience their inner lives. For all you know, everyone else might be a philosophical zombie, acting conscious but having no inner experience at all. In a simulation, this problem takes on a practical dimension. If consciousness is computationally expensive, perhaps not every apparent person in the simulation is fully conscious. Perhaps only a few beings have rich inner lives, while the rest are sophisticated but unconscious programs designed to provide a believable social environment for the conscious entities. You might be one of the few truly conscious beings in your simulation, surrounded by unconscious actors playing out their roles. Or you might be one of the unconscious ones, a zombie who processes information and responds appropriately but has no real inner experience. The disturbing thing is that you couldn't tell the difference from the inside. An unconscious zombie that perfectly mimics consciousness would, by definition, believe itself to be conscious. But perhaps this line of thinking is too pessimistic. If consciousness emerges naturally from complex information processing, then any sufficiently sophisticated simulation would likely be filled with conscious beings. The computational cost of consciousness might not be much higher than the cost of unconscious behavior that perfectly mimics consciousness. In that case, a simulated world would be genuinely alive with minds, not a hollow stage populated by empty actors. This brings us back to the question of meaning. If we are simulated beings in a computational universe, does that diminish the significance of our lives? Or does it actually expand the possibilities for what consciousness can become? Consider what it might mean to be a conscious pattern in a vast computation. Your thoughts would be part of something larger, your experiences contributing to the overall processing of information that constitutes reality itself. Every moment of awareness, every feeling, every creative insight would be a thread in an incomprehensibly complex tapestry of consciousness that spans the entire simulated universe. In such a reality, individual death might not be the absolute end we fear. If consciousness is informational, then the patterns that constitute your identity could persist in the larger computational system even after your individual processing thread terminates. Your thoughts, your love, your unique perspective on existence could become part of the permanent memory of the universe itself. This isn't necessarily comforting in a personal sense. The continuation of your informational patterns wouldn't mean the continuation of your individual experience, but it might mean that nothing you've thought or felt or created would truly be lost. Every conscious moment would leave its mark on the computational substrate that supports all existence. These speculations lead us into territory that feels more spiritual than scientific, but perhaps that boundary is itself an illusion. If a reality is fundamentally informational, then the ancient intuition that consciousness and cosmos are intimately connected might be literally true. Your awareness and the awareness of the universe might be different aspects of the same underlying computational process, but we should be cautious about drawing too much comfort from these possibilities. If we are simulated beings, we remain utterly dependent on whatever system is running our simulation. Our entire universe could be terminated at any moment by a power failure, a system upgrade, or simple loss of interest on the part of our programmers. The cosmic consciousness we might be part of could itself be fragile, running on hardware that's subject to breakdown or destruction. Yet even this vulnerability might not be unique to simulated existence. Natural consciousness is just as fragile, just as dependent on the continued stability of its substrate. The difference might be less significant than it appears. Whether we're patterns in a biological brain or patterns in a cosmic computer, we exist moment by moment, always one disruption away from dissolution. Perhaps the question of whether we're simulated misses something more fundamental. Perhaps what matters isn't the nature of our substrate, but the fact that consciousness exists at all, that the universe has developed the capacity to experience itself subjectively. Whether that experience arises from the interaction of particles or the execution of code, it represents something profound. The emergence of inner life from outer structure, meaning from mechanism, awareness from information. As we continue to explore these questions, we're led deeper into mysteries that may have no final answers. The simulation hypothesis doesn't solve the puzzle of consciousness, it transforms it. Instead of asking how awareness emerges from matter, we find ourselves asking how it emerges from information. Instead of wondering about our place in a physical cosmos, we contemplate our role in a computational one. But perhaps that's exactly where these questions should lead us, not to certainty, but to deeper appreciation for the mystery of existence itself. Whether we're real or simulated, whether we're made of atoms or bits, we're here now, experiencing this moment of wonder and uncertainty. That experience remains undeniably real, regardless of its ultimate substrate. And in that reality of experience, that immediate presence of consciousness, we find something that no amount of speculation about simulation can diminish. The mystery isn't just whether we're real, but what it means to be conscious at all, to be aware, to experience, to question our own existence. That mystery persists whether we're biological or digital, natural or artificial, real or simulated. The question of whether we might be living in a simulation often leads us to another unsettling possibility, that we might not be alone in asking it. If consciousness can arise in computational systems, if entire civilizations can exist as patterns of information, then perhaps we're not the only ones wondering about the nature of our reality. Consider this carefully. If simulations are common, if advanced civilizations routinely create digital universes populated with conscious beings, then those simulated beings would eventually develop their own technology. They would build their own computers, create their own artificial intelligences, and eventually they too would wonder whether their reality might be computational rather than natural. This creates a strange mirror effect. Somewhere in the hierarchy of nested simulations, there might be beings exactly like us, having exactly this conversation, contemplating exactly these possibilities. They might be one level up from us or one level down, or scattered throughout the computational stack, all asking the same questions we're asking now. The implications ripple outward in ways that challenge our understanding of uniqueness and meaning. If consciousness is reproducible, if entire civilizations can be copied and run multiple times with slight variations, then perhaps you're not unique at all. Perhaps there are millions of versions of you scattered across different simulation branches, each living slightly different lives, making slightly different choices, but all sharing the same basic identity pattern. This multiplicity of selves raises questions that have no easy answers. Which version would be the real you? If your consciousness can be copied, backed up, and restored, what happens to your sense of continuity? When you make a choice, are countless other versions of you making different choices in parallel simulations? The mathematics of this becomes staggering when you consider the computational power that might be available to advanced civilizations. If a single computer can run thousands of simulated worlds, and each of those worlds eventually develops its own simulation technology, the exponential growth in simulated beings could be astronomical. Every real consciousness might give rise to billions of simulated ones, creating a pyramid of existence where the vast majority of aware beings exist in layers of digital reality. Yet even this vertiginous possibility contains strange comfort. If consciousness can exist at any level of this hierarchy, if your experiences matter regardless of how many layers of simulation separate you from base reality, then perhaps the question of authenticity becomes irrelevant. A simulated emotion feels just as real to the being experiencing it. A digital sunset can be just as beautiful as a natural one. Love doesn't become less meaningful when it exists between patterns of information rather than arrangements of atoms. But there's something else to consider, something that might be even more profound than the question of whether we're simulated. What if the act of seriously contemplating simulation theory is itself changing us? What if by considering that reality might be computational, we're beginning to see ourselves and our world in ways that transcend the traditional boundaries between natural and artificial? This shift in perspective might be more important than the answer to the simulation question itself. When you begin to think of consciousness as substrate independent, when you consider that information might be more fundamental than matter, you start to see connections and possibilities that weren't visible before. The boundary between mind and world becomes more fluid. Your thoughts and the reality you think about might be part of the same computational process, different aspects of the same underlying information system. The separation between self and environment, between observer and observed, might be artifacts of a limited perspective rather than fundamental features of existence. This isn't just philosophical speculation, it has practical implications for how we understand identity, relationships, even ethics. If consciousness can exist in digital form, if it can be copied and modified and transferred between substrates, then traditional notions of individual identity become complicated. The self might be more like a flowing river than a solid object, maintaining continuity through change rather than persistence through stasis. So here we are, at the end of our long journey through questions that have no easy answers, having travelled together through landscapes of uncertainty that might themselves be made of nothing more than information and light. We've explored the possibility that everything we know, everything we are, might be patterns in some vast computation. We've considered what it would mean for consciousness to emerge from code rather than carbon, for reality itself to be digital at its deepest level. And what have we found? Not certainty, but something perhaps more valuable, a different way of seeing, a recognition that the mystery of existence doesn't depend on whether we're made of atoms or bits, whether we're biological beings on a rocky planet or digital patterns in a cosmic computer. We're still here, still aware, still capable of wonder and love, and the kind of deep questioning that brought us together tonight. The simulation hypothesis doesn't solve the puzzle of consciousness, it transforms it. It doesn't answer what it means to be alive, it opens new ways of asking. And maybe that's enough. Maybe the value isn't in reaching a destination, but in allowing these ideas to change how we move through whatever reality we inhabit. Whether this moment is happening in base reality or nested 17 levels deep in some computational hierarchy, it's real to us. This conversation, this wondering, this shared exploration of the deepest questions we can ask, It matters because we're here to experience it. And that experience, that immediate presence of awareness, contemplating its own existence, remains undeniably meaningful regardless of its substrate. The questions will still be here tomorrow, still unsolved, still inviting, but tonight you've spent time with uncertainty and found it wasn't something to fear, but something to explore. That's no small thing in a universe that might be stranger and more wonderful than we ever imagined. Rest well. Whether your dreams are biochemical or computational, the mystery will wait.